All right, I think we're ready to get started for today's webinar, which is entitled Ask Us Anything Mining Live Q&A session. So the purpose of this session is really to give to every one of you in the audience an opportunity to ask questions about how Elios 3 is used in the mining space, in the mining industry. So any very specific question you may have is it's the right place to ask answer here. And with me today I have two more people, which are Charles Rey and Michael Blake. So you guys can turn on your camera so everyone can see you. All right. So just before we get started, I would like to remind the audience a few rules of engagement. So we have a large audience today. So the first way you can engage with us during this presentation is through the question panel. So as you can see in this little video, you have in the GoToWebinar control panel, there is a section that is called questions. You have a bar when you can type your question, and we'll take those questions one after the other as we moderate the question session. And Charles and Mike are here to answer those questions. The other way you can ask questions or contribute or engage with us is by raising hands. So again, in the control GoToWebinar control panel, there's a little button with a hand. So you have to raise or click that button to raise your hand. So we'll look at that in the list of attendees, and then we'll have to give you the opportunity to speak to us. So wait for that little message that says unmute yourself. And when you get that message, is that you have the possibility to speak to us. Obviously, we prefer that you ask your question up front, and if there is any clarification or complex question, we're happy to give you the opportunity to speak, although we would rather prefer having questions coming up in the question panel. So as I said, it's a session dedicated to question and answer. So as soon as you're having a question in mind, you probably have a few already. Just enter them in the question box, and we'll take them one after the other. So as I said, today with me I have Charles Rey. So Charles Rey is Global Field Operation Managers at Flyability. So he's been with us for a bunch of years now, about 7 years. He started flying the first version of the Elios 1, and then went to the 2, and finally the 3 today. He flew those drones in all possible use cases. And as aside of that, is in charge of assessing feasibility of inspection. So he really knows how the drone reacts in the field, and how to apply or how to anticipate the complexity of mission. So that's really his role. But he's also in charge of developing training materials for trainers, resellers, and also customers. So probably the most experienced pilot on earth when it comes to Elios drones, and he's here to answer your questions. Aside of that, we have Michael Blake. So Michael is a very experienced engineer. He's got more than 10 years of experience in the mining, oil and gas sector. He's been focusing on surveying and inspection industry applications. He worked as a mechanic in the underground mining sector, and he also worked on oil platform, oil rigs. He's been doing visual and entity engineering. So he has a bunch of field experience, and he joined us recently as a product manager for what we call the 3D surveying package. So all the offer that we have specifically for mining. And before that, he worked with a company you probably know as well, which is called SenseFly, also as a product manager. He worked on the development of the EBX and the EB Vision, fixed wing platforms. So as well very experienced in the drone space. All right, so that's it for the presentation. So please don't hesitate to get started with asking your question or raising your hand as you have a question coming up. Just before we take question, we start answering questions, I just wanted to go through a quick reminder on the benefits of the Elios drone in the mining space, and what makes Elios the very good partner for all your inspection in the mining space. So first of all, this aircraft is really designed to fly where no other drones can. So due to several things, but first of all, its size, it's a small form factor when it comes to aircraft that can lift quite some weight. It's collision resilient, so it's definitely made to recover from very tricky situation and collisions with the surrounding environment. So that's really what makes our drones, the Elios series, very, very special. It has this built-in mapping payload option, which is really what we are going to talk about most today. It's designed, it's based on LiDAR from Ouster, the OSO 32, and coupled with the GeoSLAM Connect software. It's able to offer a SLAM-based LiDAR mapping with plus minus 0.2% drift and plus minus 1.5 centimeter accuracy. And the last thing is it has a built-in inspection payload. So it's a very versatile tool. It's not only an inspection tool or only a mapping tool, it's actually both. And it's pretty efficient in both fields. As in the inspection field, we have capacity to capture images with a resolution of 0.18 millimeter per pixel, which means that a millimeter in an image is represented by 5 pixels. So it means that you have a capacity to see a lot of details. It's coupled with this very well engineered lighting system that has dust-proof feature, very convenient for your industry, and very powerful because we have built-in 16,000 lumens of light. So that you probably already know all of that. Last point I wanted to touch base upon is the type of data output. So the Elios drone used to be a drone that was capturing visual data. Now, as an outcome or a data output, we also have point clouds and 3D models that are of interest for industry. And last thing that I wanted to touch base before we go on with the questions is applications. So there's a ton of applications or use cases that can be addressed in the mining space. If you're not familiar with that infographic, it shows visually all the places where Elios 3 has a value for in your specific industry. And that starts above ground in processing plants where there's a lot of places that need regular inspections. I'm thinking about crusher, ball mill, sag mill, flotation cells, all the equipments that is used to process ore and extract the material of interest. And it's very frequent that you need inspection there. It's dangerous places to enter, so that's a very convenient tool to perform visual inspection. But at the same time, next to that, you have stockpile of material that you need to measure. You need to get volume of that. And again, the tool is versatile and allows you to address both application above ground. Now, when it comes to underground, due to its small form factor size and its capacity to bounce off its environment, it can really go pretty much everywhere in all the workings that you create when you need to extract ore underground. So whether it's shafts or ore passes or much larger working like stopes where you need to assess for overbreak, underbreak, measure volume, whether it's to know where you stand with extraction or whether to calculate backfill volume, it's very, very versatile and it addresses a wide array of use cases. But I think that's enough for the presentation of Elios 3. I think you probably know most of that. Let's go to your questions, and we have a first question. I guess this is rather for you, Charles, or maybe Mike. You let me know who wants to take the question. So, what are the best practices to get a good scan of reflective ground control points? Maybe Charles, you want to take that one,
Okay.
or Mike?
I can take that one.
Right.
So yeah, best way to scan a target in our experience is actually to place minimum, really the minimum is 4 targets. A good practice would be between around 6. This way you have redundancy in your target and you have a higher accuracy in when you are scanning them. And in our experience and our tests, the highest accuracy were when you were doing a slow 360-degree turn in front of each target at the beginning of the flight. And on your way back, you just fly in front of them just to help for global optimization. So it's important to spend between 2 to 3 seconds in front of a target, but ideally not by being static. Really, you get in front of the target, you do a slow 360-degree turn, it should take about 2 to 3 seconds max, and then you fly to the next one. You're unmuted, Marc.
I was saying, Mike, do you want to add something to that, or you're happy with that answer?
Yeah, I can add to it for sure. I mean, yeah, as Charles said as well, we're supposed to circle around the target. So I actually have one of the targets here in front of us. When it comes to the actual target specification itself, we are about to start installing these targets. They're at 220 millimeter by 220 millimeter targets with a diamond reflective pattern on them. So these can be placed inside the stockpile area, inside or at the entrance to a stope, in a gallery in the mine. And as Charles correctly said as well, the idea is that we want to circle the target with the LiDAR. So to minimize any of the blind spots with the LiDAR, because the LiDAR is mounted at 45 degrees, we want to circle the drone around to make sure that we get enough reflective value on the targets. On top of that as well, it's very important, as Charles said, that we also scan the targets at the very, very start of the flight and also at the end of the flight as well. So we do a loop closure, and also from there, then GeoSLAM is better able to global optimize. What we mean by global optimizing is that we can remove any of the error or drift that we accumulate during the flight. So if we take off, we scan our targets, we go into, let's say, example, a riser, or into a stope. From then there, when we come back down, we want to circle the targets again, and also we want to land quite close to where we took off from. So that really helps to minimize any drift factor, any error factor that we can accumulate throughout the flight. And with the targets then, we're able to georeference the data set by getting the center point of the targets using maybe a total station or a different type of laser scanner.
Good. All right, thank you for your additional comments. So the next question was, how many reflective targets should we use to get the best data? I think you already answered that, Charles. So that was between 4 and 6 targets, right?
Yeah, so the strict minimum for the system to work is 4 targets. However, if you only put 4 targets, there is a chance of drift if one of the targets have not been scanned properly, or if the total station that took the measurements was not done properly, there is a chance of having a little drift, having a little lack of accuracy that would be hard to detect in the survey panel error tool in GeoSLAM. If you have between 6 to 7 targets, then you would very easily detect a drift or a shift in position. So best practice would be to use 6, but then the more you have and the more spread they are, the better will be your accuracy. Yeah, I'm sure Mike have a little bit more details about that too.
Yeah, actually,
sorry, go ahead, Mark.
Why do we need so many targets, actually, Mike?
As Charles said already, it's to make sure that we can properly geolocate the data sets or the flight that we want to georeference. But also the fact as well is that sometimes we actually want to fire in the center point of the target with a reflected shot from the from the total station. Sometimes the targets are at angles, or different attitudes, a reference to the total station. Obviously, we want to minimize the amount of setups of the total station, which means that we don't accumulate error while we try to get the center point of our targets. So really, we want to optimize where the targets would be, reference to a single or maybe 2 locations or 3 locations of the setup from the total station. But yeah, easily if the target is mounted at a different angle and we try to get the center point with the laser of the total station, we can actually slightly miss the target unless we put something like a piece of something in front of the target to make sure we get the center point of the target. So if we have only 4 targets and we do have a bad reading in one target, it may not be detectable when we go to processing and georeferencing the data set. But if we have more than 4 targets, 6, 7, 8, or as many as we can place safely within our line sight, from there, then if we do have a bad reading on a target, it won't affect the geolocation accuracy of the data set.
Okay, good. So just a quick reminder to the audience, there's 2 ways that you can engage with us. Just don't hesitate to put your questions directly in the question panel, or to use the raise hand button at on the GoToWebinar control panel, and we can also let you ask your question directly. So without further ado, I'll take the next question that's coming up. So actually, there's a question. So on the typology of targets or ground control points, what are the best, the most suited ground control points targets to use with the Elios 3? Is there any recommendations that you can give us?
Yeah, so on the targets themselves, as I said, we will be reselling these into the future quite soon, but they have to be a minimum size of 200 millimeters in target. The reason for that is that the GeoSLAM algorithm is basing itself on computing the centroid of a target based on the reflection value of the size of target. So its algorithm is based on the 200 to 300 millimeter diameter or square range. The reason for that is that in GeoSLAM, we automatically detect the centroid of target. So in other softwares, we have to go manually zoom in on the data set, try and get the centroid of the target. It's quite difficult actually to do that, especially with the LiDAR points. But here, GeoSLAM is actually automatically detecting the centroid of the target. And from then, when we detect the centroid of the target, we can then place a coordinate on the centroid of that target. So for minimum recommendations for our targets, we recommend 200 by 200 or 300 300 by better diamond reflective targets. But as I said already, we will be reselling these quite soon into the future. So you can have the whole SLAM package, which will include these targets as well as GeoSLAM.
Yeah, that's a great addition, and will make the life of everyone simpler, just to go and source those targets directly from Flyability. So very good points. There's actually another question still on the georeferencing. Can you explain a little bit the difference between target alignment and target georeferencing? What's the difference?
Yeah, absolutely. So both workflows are in the new version of Connect 2.3 from GeoSLAM. They can use or utilize the targets for 2 different types of workflow. So one is alignment of different flight plans or different flights that we did, and the other is to be able to geolocalize the actual flight as well. So let's say, for example, we're flying a stockpile, we're doing inventory stock check every 2 weeks. We do a flight with Elios, and we want to align different flights together to compile them as one area or one flight to align all of the flights. From then there, it's easier for us then to do our volumetric calculations once all the flights are aligned. So in GeoSLAM, you can manually align each of the data sets together, which takes a little bit of time to do. But better still, what you can do is you can, once you purchase these targets, you can permanently fix the targets around the inside of your inventory stock location. From there, each time you do another flight in GeoSLAM, you can just reference the new scan based on the old scan, and you can do that every time as well. So every time you do a new flight, you can then reference the new flight to the old flight and make sure that every data set is aligned correctly with each other. And from then there, we also have a product called GeoSLAM Volumes. GeoSLAM Volumes then allows us to import the process data from GeoSLAM, and every new scan will align on top of the old scan, And from then there, it's very easy to calculate the newest volume for the influence stock. So that's the alignments workflow. From the georeferencing side of the workflow, you are able to, as I said already, be able to calculate the position of this using a total station or a different type of laser scanner, and then georeference the new point clouds you did. So, for instance, we did a project in the US where we flew a riser and we placed the targets on the outside of the riser. We flew the drone in, flew the drone out. We measured or we scanned our targets before and after we did the riser flights. From then there, we shot in each of the targets with a total station. We produced an XYZ coordinate file on a local coordinate system of the mine, and we brought that into GeoSLAM, and then GeoSLAM did a transformation of the data set and brought that in line with the targets. So our actual root mean squared error on that single flight was actually 22 millimeters, so extremely accurate.
Good. Yeah, thanks for that very clear explanation. So just before we move on with the next question, I just want to say that we received quite a few questions through email prior to this webinar. So we're going as well through all those questions. So we're bouncing from question live and question from the email. But please don't hesitate again to ask your questions in the question panel. If you have anything else that you would like us to cover for today. That's really the purpose of this webinar, is to answer all your questions that you may have on the Elios 3 and how it's used in the mining space. So the next question is about coordinate systems. So now that we have those georeferenced point cloud using targets, so what is the coordinate system that is going to be used when point clouds are georeferenced by GeoSLAM?
Yeah, so depending if you're working on a national system, a local system, or you know, a system based on a local mine, a local point, whatever it would be, you can bring in any coordinate system into GeoSLAM once it's in the XYZ format. So it has to be a Cartesian UTM XYZ format, and also it has to be converted to meters. There will be an update of GeoSLAM that will be working in feet, imperial and metric as well, but at the moment it's just working in metric. But in terms of coordinate systems, you will have to convert the coordinate system that you're using into XYZ, and then you import it directly into GeoSLAM, but it will still be referenced based on the coordinates that you converted to.
Okay, that's pretty clear. Thank you for your answer, Michael. So now a question that is more related to features of the drone. There's a question on the range of signal or range of communication of the drone. So basically, how far can you fly? You know, what's the maximum distance? Maybe for you, Charles.
Yeah. So it will depend on the geometry of your well, in the ground you mine. So the signal of the 2.4 gigahertz signal coming out of the remote control in the drone do not bounce much on walls, meaning that if you have two 90-degree angle in a tunnel, you might start to lose the signal slowly after the first one, and you might completely lose the signal after the second one. However, in direct line, we did flew over 600 meters straight back and forth without any issue. In raises and in shaft, we did flew also similar distance, sometimes one way, sometimes up and down. The alternative that we found to really help for the signal was the development of the range extender that we did for Elios 1. The idea was to have a 20-meter or 60 feet cable with an antenna at the end. And this was really good to be able to place the antenna perfectly under an ore pass or from the top inside of the ore pass, and to be able to actually deport this signal straight into the tunnel. This way we make sure that the pilot is in security far away from the bottom or the top of the manhole, but the drone still have a perfect signal when he flies in it. Then in open space or in straight line, usually it's not the signal that cause issue, but more the flight time. Except if you start to fly at the maximum speed, meaning 6.5, 7 meter per second, you will never never hit the end of the signal. So it's really more the tunnel and the confined tunnel and bends that would limit your signal. But anyway, you will see it. You will see the strength of the signal on the tablet, and you will get warnings when the signal starts to lose some strength.
Cool. Thanks, Charles, for this in-depth explanation of the limitation of the signal, or actually not much a limitation, but anyway. Another question now on the alignment and georeferencing of point clouds. So can actually 2 or more point clouds be joined in GeoSLAM, working with the same coordinate system, obviously? So the idea or the question from the audience is, can we merge two flights together, right? So to make only one. Maybe Mike, you have some experience with that.
Yeah, absolutely. So it's absolutely possible to do that in GeoSLAM. There's a couple of different techniques you can do, but let's say if we're flying a gallery, we want to join 2 parts of the gallery together. We can do a manual alignment first. So we do need about 10 to 15% of overlap between the 2 flights. Let's say if we're flying a gallery section, to make sure that we have enough points data to be able to merge the flights together. Also, what we can do as well, we can use our target workflow. So we can place the targets along the inside of the gallery, for example. We can do 1 flight, so we circle our targets, we fly along, we do our section of the gallery that we want to do. We come back, we fly our targets again, we close the loop. Then we can actually move everything to the next location, fly that section of the mine with our targets as well. Once they're georeferenced correctly, using total station of the targets, from then there in GeoSLAM, you can import both flights, you can georeference both those flights, and you can actually merge them together as well into 1 flight. So I think the idea behind Diego's question is to be able to merge the flights together into 1 and also have them georeferenced. So that's absolutely possible.
Good. So now just you just have to try and play around with GeoSLAM so you can merge flights together. And I'm curious, Mike, how long does it take to actually process, georeferencing and do this whole operation of merging 2 flights?
Yeah, so if we take it per flight, so let's say our flight is 8.5, 9 minutes of flight, we produce our point clouds to process our point cloud then. If we use the standard workflow within GeoSLAM, it takes around, depending on the power of your machine, locally processing, it takes between 25 minutes and about 35, 40 minutes to process 1 flight. From then there to do the georeference workflow, it's actually very, very straightforward. It's maybe 5, probably less than 10 minutes anyway to run the registration algorithm to geolocalize the new point cloud. So in total, you're talking maybe an average around 40, 45 minutes to do the processing and also geolocalization per flight.
Good. All right. Thank you very much. There is another question. Well, it's actually related to the software. So, do I need a GeoSLAM Connect license for my mining application, or is Inspector enough? Can you just touch base on the difference between those 2 software? Maybe Mike, that's a question for you.
Yeah, absolutely. So when you do fly the Elios 3, we already produce a live LAS we fly. So you can export this live LAS file from the drone. So that live LAS, we are running a SLAM algorithm on the drone itself, and we do produce a 3D point cloud, as you see on the Copla application. So what's the main difference between the 2? So Flyware produces a live LAS on the fly. And then GeoSLAM is looking at the high density data, post-processing, loop closure, and global optimization. So the main 2 factors is the point density and also the drift factor between the 2. Flyware, even though it looks like it's sometimes a very nice algorithm, it produces very nice models. The point density is only around 2,000 points a second as a drone flies, so it's a lot less point density. Also, we accumulate more drift on the Flyware model, so we have a drift factor of between 2 to 5%. So on a longitudinal asset, let's say a stope or a drift or an overpass, etc., that can accumulate to 10, 20 centimeters of drift depending on the length of the overpass. So if you're really looking for high accuracy geolocation, the Flyware does do a very good job, but it won't give you the same output, let's say, drift factor compared to GeoSLAM. GeoSLAM itself has a drift factor of between 0.5 to 1% of drift. Also in GeoSLAM as well, you're able to run all the different types of algorithm. You can do filtering, you can do the target workflow, as we already explained. You can even do convergence too. So if you're looking at a stope where you did one flight and then you come back a few weeks later to the second flight, you're looking at rock movement, we can also do convergence as well, monitoring inside GeoSLAM itself. So there's a couple of examples between the two. But it depends what works for your application. Are you looking for very high accuracies with the GeoSLAM, the loop closure, etc., and all the added features of filtering? Or sometimes, in a lot of cases too, the Flyware model actually works quite well, but it has to be manual lines, georeferenced in a different software to be able to use it.
Thank you for your answer. So there's a question on the usage of the drone and use case. So is it possible with the Elios 3 drone to inspect gas handling pipelines from copper concentrate smelters? Charles, you want to take that one?
I actually don't really know what it is from your description.
Yes. So maybe Christian, you wanna precise a little bit the size of those pipes. What else do you need to know, Charles, to answer that question?
The size of them, as what do you want to inspect actually? What's the objective of the inspection, and what are the criteria of success? And the length of those pipes. So how many meter or feet do you need to cover from one entry point to the next one?
All right, maybe what I can do. So diameter of the pipe is 1 meter. Maybe Christian, I will unmute you. I sent you a request. If you want to unmute yourself, just accept the request and complement your question so that we can help you out. But so diameter would be about 1 meter. Christian, do you hear us?
Yeah. Hello, guys. How are you? Christian Fritis from Alto Norte Smelter. And I have an idea. We have a lot of ducts, the pipes were 1 meter for diameter for handling gases to the smelter, to the acid plant, and we have a problem with corrosion there. And we know when the ducts is broken. In this moment, with the film, we know we have a problem there. The idea is possibly use this drone for a preventive inspection in shutdown and put inside this ducts and check all the pipe between a smelter and acid plant. I don't know if it's possible.
So flying in a 1 meter diameter pipe is possible. You might have issue if you want to process it through GeoSLAM, simply because the pipe has exactly the same shape and the LiDAR do not like that. However, flying and doing a visual inspection is possible. Then your visibility will be limited by the quantity of rust and dust that you have inside of them. Sometimes the pipe are pretty clean and you can see pretty well. Sometimes you have a lot of dust inside of it, rust dust, and that will fly when you are fly around the drone when you are flying inside of the manhole, inside of the pipe, sorry, and it might limit a little bit your visibility. Depending on how far you need to fly between two openings, this could be more or less problematic. I also remember that we had a customer doing that kind of use case that actually wet the pipe a little bit before the inspection. This was putting all the metallic dust and was like gluing together the metallic dust. And by doing that, he could fly with no dust at all inside of the pipe. He had an opening more or less every 100 meters. So he was flying from one entry to the next one. He was doing one-way flights during his inspection, and he was looking for big defects, and that worked perfectly well. With 1 meter diameter size, you will maybe be a little limited by the distance that you can cover. So if you have only one entry every 500 meters, that's going to be a problem, because it's difficult to fly fast in a very confined environment. But if you have one entry point every 100 meter, 150 meter, that shouldn't be an issue at all.
Okay, thank you.
You're welcome.
Thank you, Christian. I'm just gonna mute you again. There we go. All right. Next question is about training. So do we have, does Flyability has a GeoSLAM training available? Something specific about using GeoSLAM Connect? That's probably for you, Charles.
So I'm working on one 100% online version. Should be available in the next 2 weeks. So that would be something with video, quizzes, and certificate at the end, and a couple of data sets and example of how to process data in GeoSLAM. So I've been working for a long time on it now, and normally in the next 2 to 3 weeks, it will be available for everybody. Yeah.
Okay, so just be patient, but it's coming up, and by experience, I've seen many of Charles' training. They're very complete and well done. So I'm sure you'll get everything you need with that training. So there's again a technical question regarding scanning. So what is the smallest volume you can scan actually with the Elios 3? I'm pretty sure that's related to you know, can you fit inside or passes, or what, you know, what's the minimum size you could scan? I don't know if who wants to take that one.
Yeah, I can take it. Yeah, we started to do some tests actually on, let's say, the minimum size that we can scan, especially when it comes to the sewer environments as well. We're going to fly down the sewer to do mapping of sewers. So the minimum size, some of the size we tested is around 600, 650 millimeters in diameter. But it really depends, the success, let's say, of the generation of the point cloud really depends on the type of texture that's inside. So if it's a very textured environment where the LiDAR has lots of key points it can pull from, then we've a far better chance to be able to reproduce the point cloud. If it's a totally smooth steel pipe or a smooth concrete surface, then it's a little bit more challenging for the LiDAR to be able to produce a very nice map. There is some algorithm adjustments, presets that can be done already in GeoSLAM. So if you're flying a confined spot environment, or you're flying inside a tunnel, there already is presets to adjust the algorithm based on the type of environment that you're flying in. But yeah, we have flown in 600. Actually, we recently flew a sewer. That was a brick sewer that was 1 meter in height and 600 meters in diameter. It was more like an oval shaped cross section. And the point cloud worked really well, actually. We produced a full point cloud from the flight. So yeah, we do face a little bit of challenges when it comes to symmetrical environments, something like the ducts actually that we just spoke about as well. But in some cases, depending on the type of texture, what's inside, do we have some way to reference the points from, we can get full success as well. So it really kind of depends on the application.
Great, thanks for that detailed answer. So another question again regarding GeoSLAM Connect. Regarding the future of the software, so what are so there was recently this addition with the target alignment and georeferencing, but is there anything new that is coming up, or what are the next improvements that are expected with GeoSLAM Connect?
Yeah, so on GeoSLAM Connect, actually, it kind of follows on a question from what I spoke about already. It's also related to mining too. So in GeoSLAM, we process as a rigid format. So that means that the model itself is, when we do the loop closure and global optimization, it's a rigid transformation system. However, in the future, what we're working on as well is to do a non-rigid transformation system, and that's mainly to help us in smaller environments like sewers, etc., and also to reduce the amount of drift that we experience sometimes in flight. And the way we're going to do that is actually using the target workflow to be able to redistribute some of the points based on the coordinate system as well from the targets, and then do a reload optimization of that to be able to I'm trying to get the term, but to reload optimize and redistribute any of the points which might be weak in some of the areas of the point cloud. So that's one of the key things we're working on as well. But there is a couple of things in the background. I'm not sure how much we can actually talk about, but it is very exciting. But we're definitely focusing on different industries, especially in mining, anything underground related. So.
Yeah, I think what's important also to remember is that we have a long-lasting relationship, or we're forging a long-lasting relationship with GeoSLAM. So we're working hand in hand to improve basically the mapping workflow with them, you know, progressively as we receive feedback from clients. So I think this is also a really good, really important point to mention. Another question about accuracy. So how is the accuracy of the point cloud estimated to achieve topographic quality? Does GeoSLAM show any processing reports? I guess that's more for you, Mike.
Yeah, so GeoSLAM does actually produce a quality report. It's quite basic, but it's something that will be coming as an update in the next version. So it does give a root mean squared error between the actual, so it gives you actually a report of the processing, the global optimization, a drift factor, and from then there as well, it gives you, if you georeference based on the targets, it will give you a root mean squared error reference to the targets as well. So recently, as I said, in one of the flights that we did in the mining section where we flew drift, we had 7 targets placed, and we got a root mean squared error of 22 millimeters, I think, off the top of my head, between all the targets. So we got a really, really high accuracy model. And that was really thanks to the loop closure and global optimization workflows that Charles developed, which will be available soon.
Cool. Yeah, thanks for that. And so how would that compare to a terrestrial scan in terms of accuracy, actually?
Yeah, so actually in the same paper that we developed as well, we actually tested a faro scanner. So we flew Elios and we flew the faro scanner in the same environments, and the results actually were quite similar. So when we think about the Elios, we have over 320,000 points per second, where the faro scanner has, I think, over 1 million points actually. So the density and the precision was a little bit better from the faro scanner. So we're able to get a sub 1 centimeter of precision with the faro scanner. With the Elios and the LiDAR, we get around the 2 centimeters of precision plus or minus. So depending on the type of application, the mining application, we strongly believe that the Oster precision from that is very, very suited type of use cases. But also when it comes to efficiency and speed and mapping is one of the key things, especially in the mining environment as well. What we see is an increase of around 60% of speed in terms of the actual mapping when it comes to actually flying the Oster on the Elios. Also, we can access areas where we would never be able to access before. Since we have technically a flying LiDAR, we struggle to get to the terrestrial scanners into because of safety reasons. There is other scanners in the market like the CMS, the cavity monitoring systems on a pole, which is very similar to the Oster LiDAR, which is on a pole, but still it's very, very difficult to get a true mapping in some areas. So the amount of area that we can cover compared to a terrestrial scanner is quite enormous actually, and also the safety factor as well we think about as well. So in terms of efficiency and safety as well, you know, Flyability's model as well as to put people in less danger. And this is one of the key factors as well of having a flying LiDAR in these situations where maybe a roof structure is unsafe, there's falling rock, there's water ingress, etc., into mining sections where people can't go. With this on top of the Elios tree, we can still get really, really nice high dense point clouds. And then we can also merge as well, which is nice. If you have some terrestrial data and also Elios data, we can merge those point clouds together as well in the future of Connect as well. So, so some nice features coming as well that be able to help merge different scans from different equipment as well with Elios to produce a nice 3D model.
Cool. Well, thanks for that detailed answer, Mike. We're getting close to the end of this webinar, but please still go on with your question if you have remaining question. I have one more here. So what is the range of the LiDAR that we have mounted of the on the Elios 3?
I can take this one if you wish, but so the range of the LiDAR is technically the range is up to around 100 meters, but the usable range, so what I mean by usable range is the range with the best accuracy and precisions is roughly around the 40 to 50 meter mark. But then again, that really does depend on the reflection value of where you're flying. So if you're flying inside a let's say a stockpile area with nice concrete walls, we get very, very good reflection. If we're flying down a mine with the bare rock walls, we have a different reflection value. So the usable range sometimes depends on the areas where you fly and the environment where you fly, but in general, the usable range is between 40 to maybe 60 meters, but the overall range is up to the 100 meter mark.
Good. Yeah, thank you, Mike, for that answer again. So we're slowly reaching the end of the list of questions. I just wanted to thank everyone for joining us today for this first live Q&A session that we organized. It's been a very pleasant exercise, and again, we really appreciate your contribution with questions to make that moment interesting for all the audience. Obviously, there will be a recording of that webinar that will be shared afterwards, so that if you want to come back to some of the questions or listen again to the answers, you're more than welcome. I also wanted to thank Charles and Michael for taking the time to come and contribute with all their knowledge. We're looking forward to the training, Charles, as well, so that everybody is self-sufficient in learning GeoSLAM Connect with the Elios 3. And yeah, just wish you a pleasant evening or rest of the afternoon, and we'll see you soon. All right, have a good one. Bye bye.
Thanks everyone. Bye bye.
Bye bye.